Okay, this is the big final review day. We have a whole bunch of topics to cover for honors higher algebra for your final. And the first thing that we haven't talked about, that I want to talk about, is matrices. Do you remember these? You'll need a graphing calculator to take it out because we require some pretty heavy-duty stuff like finding inverses, even inverses of 3x3 matrices, which you can't do by hand. So if you need to borrow a calculator, this is the part where you should come up and bring me that collateral, and I'll hand you a borrowed calculator. All right, so everybody, kids got their calculator. To start with, do you remember problems like this? Remember problems like that? And you're trying to solve for x and y. And so what you do is this would be a matrix A, and this you'd call matrix B. And then, well, to get the x and y alone, do you get I want to get rid of this? What gets rid of A? Inverse A. All right, so this is the part where we're going to do inverse A on both sides. A to the -1 here and A to the -1 here. And then this will cancel this. And technically, this is what's left. Just a quick reminder. Do you remember how the ones go kind of like this? I should use a bracket, not a parenthesis. 1, 0, 0, 1, that's like what 1 is. If that was in front of this, that just means 1 xy. That's the matrix way to say 1. That's what you get when you multiply inverses. All right, so anyway, back to this. If we can just do this part, A -1 B, that's inverse of A times B, this will be where you'll get your final answer. Okay, so let's see if you can put in the A matrix. In case you forgot, I'm going to show you. That's the A matrix. Here's the B matrix. And then we'll do inverse A times B. Again, this is a review video, so this means you should already have the basics of this down. Just reminding you of the nitty-gritty, complicated stuff. Pausing while we load this up. Okay. So I'm going to quit out of my graphing mode that I was in. Next thing I'm going to do is make sure that under the mode screen, excuse me, some people are talking, that you get into function mode. If you aren't already, get in function mode. If you're in parametric or polar sequence mode, this is going to get all messed up. All right, next we're going to go to matrix, which is right there, and enter in the A matrix. If you haven't already done this, follow along. If you've already done it, awesome. All right, so first I got to enter and edit the A matrix. So I got to arrow over to edit, and I'm going to hit enter, and now it is already a 2x2. If yours was bigger, you'd want to set it to a 2x2, and then we're going to put in 2 and 1 and 3 and 4, and then I'm going to go on to matrix B. So I'm going to go back into matrix and find and edit the B matrix. And the B matrix is 1, 0, -3, 2. Oop, first I got to make it a 2x2. 1, 0, -3, 2. All right, and then I'm going to go back out. I'm going to quit, actually. Then I'm going to have a nice clean screen here where I'm going to drop the A matrix. And now how do I do inverse of A? A to the -1, like that. And then I'm going to say times the B matrix. Back into the matrix menu to pull up the B matrix. And enter. Yay, except the test is going to say, write your answers as fractions. Do you remember how to change those into fractions? Hint, it's under the math button. Math, enter, enter is the nice simple shortcut. And there you go, 7/5, -2/5, -9/5, and 4/5. Yes, sir.
For this question, wouldn't the B matrix have to be a 2x1?
No, not necessarily. Now, I get what you're saying. I do. And I'll show you one in a second where it will be a 2x1. Okay, but this isn't, you could be asked to solve this. This is a real question. And anyway, I'm going to get to, you're right though, a more typical scenario goes like this. You have two equations. 2x plus 3y equals 5. And negative 3x plus 4y equals negative 12. Those are two lines that cross. And this matrix thing we just did could tell you where they cross. This one is going to be a 2 by 2 and a 2 by 1. All right, would you please write the matrix equation? And the kid who asked that question, you make a good point. We never did it the way I just showed you. And technically what we solved for there was a 4-part matrix, not a 2-part matrix, not a 2 by 1. So the one I'm following up here with, this is even better. More likely to see this kind. Did you figure out that it's 2, 3, negative 3, 4? Raise your hand if you had that part right. Okay, awesome. And from here, it's pretty simple. X, Y, 5, negative 12. You put this in matrix A, you put this in the matrix B, and if this is A, the one we want to get rid of is A. So you do inverse of A on the left side of both. Why did I say on the left side of both? So many details in math. If you do that, it's not the same. If you do BA negative 1, B times inverse of A, that won't work. You know why? Because multiplying inverses backwards, actually multiplying anything backwards in matrices land, gets you a different answer. In normal math, 3 times 7 equals 7 times 3. But not with a matrix. A times B does not equal B times A. All right, so we have to have this A inverse over here on this side times B. Save me the time of putting all that into my calculator. What'd you get, sir?
56.
Oh, these are fractions. Okay, 56/17. Here, I'm going to start over again. So the matrix looks like this. 56/17 and what? Can anybody verify that they got the same thing? Okay, good. So what else do you have to know about matrices? You could be asked for the determinant, the DET. Here, let's just keep these the same so you can just use one matrix that's already in your calculator. Would you please find the determinant of the A matrix? The DET, the determinant. Now, I'll show you how to do it by hand in a second, but see if your calculator can do it for you. Use matrices, use calculate. Okay. I betcha that you got 8 minus negative 9, which would make 17. Can you guys verify 17 was the answer? Do you get what I just did? I multiplied the 2 times the 4 and got 8. And then I multiplied the 3 times the negative 3 and got negative 9. And I subtracted them. The reason you care is that on the test, what if we do this? 2A, 3, 5. And we say, what's the determinant? It's not hard if you know what gets multiplied and subtracted. Give it a shot. Your answer has an A in it. That means it's in terms of A. That's how you say that. You should have said 10 minus 3A. Does that make sense to you? Okay, that's determinant. What about the inverse of it? Ew. I don't think we would do that to you on the final, inverse by hand, like where it's a variable in it. But just in case somebody was evil and decided to put that one in, I don't want to be the one who said it wasn't going to be there. So what would you do again? Well, you go 1 over the determinant times, is it just these 4 numbers? No. You take the 2 and the 5, and do you remember what you do to those two? Switch them. And the other 2, you make them the what? The opposite. So this would be opposite A and opposite 3. That's your official way to get the inverse. You do 1 over the determinant times these 2 get switched, and these 2 got to be the opposite. Okay. Can't think of anything else matrix-wise. Oh, how about the simple kind? Just in case. Like some people, I was surprised last hour. There's always somebody that's not understanding this, even though they're the easier kind. What would that be equal to? Hint, there's a multiply and there's an add in here. Make sure you don't forget to multiply by 2 at the front. Tell me what you think the answer is, and don't overthink this. This one's pretty easy. Okay, 2 times 2 plus 0 makes 2. No, it doesn't. Dang it. It makes 4. Raise your hand if you had a 4 in that first spot. Okay, good. Then 2 times 4 is 8 plus 1 is 9. Right? All right. And that makes -2 plus 0 makes -2. And last but not least, I'll use blue. 2 times 4 makes 8 plus 1 makes another 9. 4, 9, -2, 9. Raise your hand if you had that one right. Okay, awesome. That's the easy kind. That's got what's called scalar multiplication of matrices. That's where you just, this 2 scales it up. And then adding, where you just add the ones that kind of go together. The corresponding elements of the matrix. Okay, any other questions about matrices? Yay, we're done with that. Next, what about stats? So 2 kids are arguing in the lunchroom about who got a better score. One kid says, well, I got a 24 on the, no, let's make it a 25. I got a 25 on the ACT. And the other kid says, well, I got a 1200 on my SAT. So who did better? Would really help if you knew the average and the what? Standard deviation. Okay, I will tell you what we're going to use, and these are not perfect, but they're close, is an average of 21 ACT, and the standard deviation would round to anyway 5. Over here on the SAT score, the average score is a 1060. Would you agree they're both above average? Yeah. So it's kind of hard to compare them. Oh, wait a minute. Standard deviation. The standard deviation is 209. We're going to call it 300. I'm rounding. So figure out whose is actually better by finding the what's. Z-scores. Very good. Find the Z-score for both. If you forgot how, I'm going to show you in a second here. So Z-score. This is kind of real. Like a lot of kids, there's about a third of the kids in the school that take the SAT, and it's really hard to compare a 1200 to a 25. So this is how you could really do it in the real world. And if you wanted to prove it to somebody, you just have to show them how you looked up the averages and the standard deviations. So you should have said 25 minus 21 over 5 And that ends up being what? 4 over 5. And what is 4 over 5? That's about a 0.8. A 0.8, what does that mean? That means they're above what? Average. And is it as much as a standard deviation above? No, that would have been a 1.0, not a 0.8. And how about Mr. SAT over here? He was also above average, I can tell. So you go 1200 minus 1060, divide by 300, and help me on this one. What did he get? What? 0.46? All right. Pretty easy to tell who did better, isn't it? Okay, because they're way closer to 1 standard deviation above average. Okay, then there's another thing that's kind of fun is, well, did I make the 80th percentile? You're all at some point going to get an ACT score, and you'll wonder, I wonder what percent that was. What percentile that was. Was I like top 80% or top 80% is not that great. The 80th percentile is a different thing. The 80th percentile is top 20%, right? Let's do that one. See what the top 20%, which would be 80th percentile, would be. There's a tool for this. There's 2 tools, basically, CDF and inverse normal. Hopefully you know the difference. We want 80th percentile on both tests. You guys ever heard of the 80-20 rule? It's a rule that happens out in real life, and it's I'll give you an example of it. We have an insurance agency, and 20% of our customers cause us 80% of our problems. Like the people who are chronically like, oh, I forgot to make a payment, and I don't know if my bill is up to date or not, or, there's 20% of, and I would bet this is true in a classroom too. Out of this group, 80% of you probably click along and never have to ever ask about like, oh, where do I turn this in? Or, it's not like a problem if you ask me a question, but there's people who are chronic, like they don't pay attention to when do I turn stuff in or whatever. It applies in so many cases. Like, I bet you that there's 20% of you that have 80% of the late work. Of all the late work that there is, 20% of kids do that. Another would be on the 80-20 would be there's probably 20% of our population that causes 80% of the problems, like police calls, this trouble that they get into. Anyway, so we're trying to find top 80th percent. So that made me think of the 80-20 rule, so I thought I'd share it with you. All right. Is it a law? No. It's just an observation. For the principal, I bet you 20% of his teachers cause him 80% of his problems. It's just an example. Most of the people don't cause the problems. Some people do, and they cause not all the problems. They cause like 80% of the problems. Okay. Anyway, when you did the inverse normal, then you wanted to know 0.8, that's 80%, and then you wanted to put in the average, 25, and then you want to put in the standard deviation. Oh, wait, the average wasn't 25. Average is 21, sorry. And then standard deviation of 5, and what did you get? Wasn't it 25.2? Okay. And that's important that you can interpret this. Did this kid with the 25 make top 80th percentile? No. Maybe? Do you think that they made 79th percentile with it? Maybe? Yeah. And you could then go figure out what 79th percentile is and see if they made that. So if it's for yourself, there's another tool that you can use that we haven't used, where you tell it what your score was and what percent is that. But we never did that, so I'm not going to introduce anything new on the review day. Okay, help me out with what score did you need on the SAT to hit 80th percentile? Help me. What did you get? Yes?
13.
Can anybody verify the 1313 number? A lot of people, yes. Good. Okay. All right. I think that's a pretty handy one that you could actually use in real life. All right, here's another one for stats. A 5-number summary. We're going to put in 5 numbers. 22, 23, 24, 24, 25. That's 5 numbers. Now I happen to double up on the 24. That way it's got a mode. If you put those into your calculator, I hope you're putting them under Stat and Edit. And I'm going to put it under L1, 22, 23, 24, 24, 25, Enter. And then I don't really care what the other one is. You know what? I'm going to just save myself time. I'm going to have you use those numbers. I'll write them on the board. 28, 25, 21. And then the last couple, 22, 20. And I wanted on purpose break the perfect little streak because I didn't want my R value to be 1 or -1. Because if it's perfect, like it just goes down 1 every single time. All right, so if you've got this data, one's L1, one's L2. First of all, the 5-number summary, that comes from the 1 variable stats. So everybody do 1 variable stats. Oops, I just did list. Stat, calculate 1 variable stats. Just do it on L1. And if I want the 5-number summary, it starts with the min. And now I can see all 5 numbers. Min, 22. Q1, 22.5. Median, that's the middle thing, is 24. Then Q3 is 24.5, and then 25. What was the middle again? Help me. 24, was it? That makes sense. Okay, from a 5-number summary like this, you can tell a ton. Like, what's the top half of my data? Between 24 and 25. What's the lower quartile? In there, between 22 and 22.5. What is Q1? 22.5. What is the interquartile range? 2, because you go that minus that. Where is the middle 50% of the data? From here to here. Okay, enough about that. Next, do you get, if I took the average of this and the average of that, that would give me my something something. Do you remember what it's called? Average point, also known as mean point. Because it's the average of the x's and it's the average of the y's. That would be the mean point. Now, it would be under 2 variable stats, but frankly, that's about the only thing we use 2 variable stats for. And couldn't you have just found the average of these by yourself and the average of those by yourself without having to, yeah, you just find the mean of the L1s and the mean of the L2s. So 2 variable stats aren't super useful, but the 1 variable stats are. And if you took a stats class, of course, you could make it useful. But for us, the 1 variable stats is kind of the more powerful one. Okay, that's a lot of stuff. There's one more that I haven't done. What percent of our data, and let's use L1. If this is our data, you should know where its standard deviation and average are because you know where to find those. What percent of the data would theoretically be between 0 and 23.5? What percent of our data would be between 0 And some of you are going to be like, how am I supposed to put in 0? You could put in negative infinity. That's even better than putting in 0. And 23.5. And do you remember what this is called again? 3 letters. Normal what? CDF is correct. Normal CDF. And it's between 0 and 23.5. Now, I will tell you, you get a slightly different answer, and it's not as accurate. If you do it the way I just did it, you really want to do from negative infinity to 23.5. And I know you're thinking, you couldn't even have negative numbers. How do you know? What about this list says that it couldn't be negative? There's nothing that says that. So you really should put from negative infinity to 23.5, and then the mean, which was 24, and then the standard deviation, which I'm assuming is like 1 point something, 1.19, 1.019 for standard deviation. There, you put all that in, you should tell me, and I'm guessing it's like 40% of the data, something like that. 46, can anybody verify 46? Nobody? That's weird. Yes? Oh, a bunch of people now. 46% of the data. All right, I'm going to pause for a second. Okay, and I think that I'm hearing the differences between the kids that did it from negative infinity to whatever, and the kids that did it from 0 to whatever. So let me show you how the official right answer. I'm going to go to calculate. I'm going to go to, no, I'm not. I'm going to go to stat. Sorry. What am I doing? I'm pausing for a second. All right, back with you. So we're going to above vars, distur. All right. So I'm going to do normal CDF. And this wants to know the lower. Look, it's already typed in there. Now, if you want a lower of 0, you're not totally understanding. You always, if you want to find everything below like 23.5, then you go from negative infinity until 23.5. A second here. And I know some of you are thinking, but 0 to 23.5 ought to be the same. No, the calculator doesn't know that it can't be negative. So it wants to have you type in negative infinity to 23.5. All right, and then we want the average, which was 24. And then we want the standard deviation. Help me again, 1.0 something. 1.019. Now that might be a difference too, if some kids used a different standard deviation. And if you'd used a different standard deviation, you'd definitely get a different answer. Question or comment? Yes?
Isn't 24 the median?
Isn't it also the mean? Ooh, then we gotta look up the, here. I don't want to quit out of this, but I'm gonna trust you. Have you typed it in and found the average and it was what? 23.6. This could be another reason we're getting different answers. 23.6. I assumed that's not a good idea. All right. Paste. And now enter. 46.1%, I guess you could argue. All right. And if you got different numbers than that, it's probably because you made some of the mistakes that I almost made there. Maybe you took the wrong number for the average. Maybe you didn't go to negative infinity instead of 0. Okay. There. Whew. Done with stats. What else is there? So much stuff. But the major chunk was 2 little chapters near the end called what? Probability. All right. So I'm going to see how much I can teach you in the remaining amount of time, and there's so many things that you could know. The way I'm going to approach this is as tools. I would bet that you will use every single one of these skills once on the final. Here's one of them, blanks. Let's say that you are making license plates for a rich guy who owns an island in the Caribbean. And he says, hey, I'd like you to set up license plates for all my little golf carts. So how many of these little, like, golf carts made by Tesla because I'm ridiculously rich. And so I've got these little golf carts. We're going to have 2 letters and 2 numbers. But, you know, eccentric billionaires are eccentric. And so they say, you know, but Q has always been my unlucky letter. So we're not going to use Q. And we're never going to repeat a letter or a number. How many license plates can I have? I'll say it one more time. It's got 2 letters and it's got 2 numbers. It starts with the letters and ends with the numbers. It doesn't really matter calculation-wise, but I was assuming the letters here. But you can reverse it, and it shouldn't matter, because what do you do with choices? You multiply them. All right. And he's terrified of the letter Q, and he doesn't want any repeats, because he's a little scared somebody's going to get the PP golf cart, and you know, I don't want that. So how many choices for this spot? It would be 26, but you can't use Q, so it's 25. And if repeats are not allowed, how many choices for this spot? 24. How many digits are there that we could pick from? 10. Did I have any restriction like, oh, but it can't have 7 because I lost on 7 once in Las Vegas? No, there was no restriction, so it's 10. And then why isn't it 10 again? No repeats, so it's a 9. All right, so blanks is something you will probably use once. All right, here's another kind. The CC question. You remember this kind? That kind of thing? Okay. But before we get to the CC, we better just do a plain old C. Like, when did you use that? Let's say there's 30 of you, and I randomly pick 2 people to give $1 million. That actually, it's going to be a game of one-on-one volleyball, and whoever wins, they get the $1 million. Can you imagine how seriously they would take the game? It would probably cause some sort of psychological damage to the poor kid who loses. Like, I had a chance when I was in freshman in high school or a sophomore or whatever you are to win $1 million, and this kid beat me. Anyway, so how many different games could there be? Well, there's 30 of you, and I'm choosing out 2s. So how many different random combos could I have had? 30C2. And would you set up the little multiply that would give you your answer? You might think, but I would do it on the calculator, Mr. Server. Not if I put 30CM. So you got to know how to do this again. Hint, it starts with 30 with an exclamation. Who knows the official name for that? Factorial. 30 factorial over 30 minus 2, which makes 28. And you're close, but you're wrong. What is it missing? A 2 factorial. On the C, you need an extra one of these. An extra 2 factorial down there. On the P, you do not need the extra thing. In case you never learned that, I have seen this come up on retired ACT tests. This is one of the things they can ask you to do. Final answer? Well, I'm not going to write out 30 times 29 times 28 times 27 times 26 times 25 because a lot of it's going to cancel. Do you get that the 28 factorial would cancel with most of the numbers up here? The 28 factorial down would cancel that. Now I just got 30 times 29 over 2. That's not that bad. I'd use my calculator and go 30 times 29, divide by 2. Or even smarter, I'd divide this and get 15 times 29, and I'd be done. What else could have done this on your calculator? Hopefully you know how to do the C button. Everybody try to type in 30 NCR2. If you haven't remembered where that was, it's under the math button, and then PRB for probability. Try it. It's not that big of a number. That's what it would have been way bigger. P. Permutations. Permutations would have been if the order mattered. Like I was picking president and vice president. And if you're president versus vice, you would say it definitely matters. The order of that matters. Okay, so this wasn't an order matters question. If the order matters, the order patters. You use the P's when the order matters. Let's finish this off, and what did you get for a final answer for that? 32? What? 435. Now let's just do the same thing, except the order is going to matter. This time, the 30 of us are going to run across the parking lot. 12-minute warning there. And we're only going to keep track of first and second place. And maybe the first time I get a certain winner, but then they pull a hammy, and so when they run the second time, there's going to be a different winner. And maybe the first and second place winners like ran so hard that they're tired the second time, and so you get a different winners. And how many different ways could they finish? That's 30 B2. It'll be significantly bigger. Is it just double? Try it. What's 30P2? It is actually just double. And why? Because if I take two kids and you're first and you're second, and then it's the other way around, you're first and you're second, so there's only two ways to do that. Why? Because there was only two people we were keeping track of. What if we were keeping track like the Olympics does, to first, second, third? Do they even do fourth place in the Olympics? At least they do first, second, third. Then there's those three people could be rearranged into a lot of different orders, and so it's not always just twice as big. In this case, it is twice as big. So your answer should have been 870. Raise your hand if you had that one right. Okay, awesome. Now this brought up this point. Do you remember me saying that if you have a deck of cards, that you could shuffle it and there's lots of different permutations? 52 cards in an order. Does the order matter? Yes. So then it's a P. So what are you supposed to do? The question is, how many different ways can 52 cards be arranged? If I say arranged, that means the order matters. So what if it's like letters in a word? If you rearrange them, does the word change? Yeah, so the order matters. What if it's books on a shelf? The whole point is, how many different arrangements can you make? So arrangement, you should think permutation. Order matters. All right. So that one about the deck of cards thing, that was 52P52. And that's 52 factorial. And that is such a big number that it is almost impossible for your brain to comprehend it. You might even be able to say what it is, because your calculator can tell you in scientific notation what it is. Do you have it on your calculator? Can you read it? 8 times 10 to the 67th. And that means that even though the number right after the 8 is actually ridiculously big, it almost doesn't matter, because I have to put on 67 zeros. And it's hard to even process that. I'm not even close to I'm not even near a halfway done on that. And that is a massive, how many zeros? 67 zeros. I'm not going to write them all. It'll just take a ridiculously long time. And that's why, remember me saying this? That if you shuffle a deck of cards, you've probably just created a new shuffle that has never been seen before since the beginning of time. One person did a great analysis of this, and they said, what if you took every person on Earth and had them shuffle cards, one shuffle per second, and then the next person, and then everybody at the same time shuffling cards. Since they were invented, we still wouldn't even have half of the combinations yet. Not even close to half of the combinations. So that means it's very likely that when you shuffle a deck of cards, you're getting a new combination that's never been seen since the beginning of time. You can do the math on that yourself if you're bored sometime this summer. All right. You remember me saying if we went out and got on a bus? So set that one up. Just set it up. We went out and there's 30 of us, and you go sit on a bus. And does the arrangement matter then? If you're sitting next to your girlfriend versus not, yeah, you know the order matters. Okay, so the order matters. And if everybody wants a seat, well, 30C30, right? No, because the order matters. 30P30. And so that's 30 factorial. And that's the one where I said, that takes so long that you could start rearranging out on that bus and never get every rearrangement, even if we kept doing it for the rest of your life. That blows my mind. It seems like, and most kids guess, that it might take a day or two or maybe a week. It's your rest of your life, and you still wouldn't even be close to having every possible permutation. Okay, so permutations are really big numbers. All right, next, let's talk about the probability tool called CC over C. There's 52 cards total in the deck. Do you know why I just put down there? Because what it's out of goes on the bottom. And you're going to be dealt 2 cards. 52C2. See if we can finish this now and do the subgroups. In the cards, in the deck of cards, there are things that are aces and there are things that are not aces. Would you agree we can make that distinction of 2 groups? Aces and things that aren't aces. How many aces are there? 4. What's the most you could get if I deal you 2 cards? 2. So figure out the probability that I deal you 2 aces. And that's an interesting point. How many cards are you being dealt total? 2. So if you are dealt 2 aces, then you had 4C2 and 48C0. Now, some kids are going to be like, I didn't know we had to do that. Well, you don't really. Because do you get 48 choose 0 is actually just 1? Choosing 0 of something is very simple. There's only one way to do it. You don't do it. That's kind of a weird answer, but it's true. Okay, so I get some people won't have used the 48C0 and they still be okay. But it's still smart to do because then it allows you to balance. I think you may recall, I told you about how that plus that equals that. And that plus that equals that. All right, use what I just showed you there to try this one. I'm going to deal you 5 cards this time. Probability you get 4 aces. That would be incredibly awesome. You could play cards for the rest of your life, and you might only have it happen once or twice. 5 cards. 5 cards, you want 4 aces. Well, there's 52C5. There's 4 aces, C4. And some people are like, so that's it. Nope. Why not? Because you don't have 5 cards yet. Should have said 48C1. Raise your hand if you included the 48C1. Awesome. Okay, there's another tool. There's so many tools. One of them is the binomial. 2C1, 90, 10. This one goes here. And then this plus this has to equal this. So that's what's got to be here. Oh, what? Do you remember this kind? I'll tell you an example. 90% free throw shooter walks up to the line. What's the probability they make 1 out of 2? Well, first of all, do you get they're actually more likely to make 2 out of 2? So the probability of them making 1 out of 2 is actually not that high. Figure out what it is. It's this. It's on the board. They shoot 2, we're making 1. So making 1. That means missing 1. And you multiply it all out, and it's not a super high probability. What did you get? 18%. Would you now figure out the probability that he makes 2 out of 2? It's going to be a much higher probability. Because he's a 90% free throw shooter. He's pretty much money. He's likely to make both. KH, what did you get for the second one? 2C2, 0.9 to the 2, and then a 0. And what'd you get? What? 81? Can anybody verify 81? Okay, awesome. then if this one's 81, was the other one 18? It's like a dyslexic nightmare. All right, so my brain hurts. Doesn't that leave only 1% left? What does that 1% have to be? Probability misses both. So what if I said, what's the probability he makes at least one? We've already got making one and making two, and we'd put those together because this or this would work. Remember, or means add? Okay, we're getting close, but we're not done yet. The last thing, Venn diagrams. And this also works for charts and stuff. This is going to be piano. This is going to be SUV. And this is going to be that your house is yellow. Okay. 2, 1, 0, 3, 1, 4, and 18, and let's say 1. What if I needed to grab a random kid, and what's the probability I would get a kid who's got a yellow house with a piano and an SUV? This and this and this. 1 out of 28, is it? Yeah, but I think I made this actually add up to 28. That's 20. 4, 5, 6, 7, 8. Oh, you're right. It's 30. I actually made that add up perfectly. Must be my subconscious working overtime. All right. What if I say and? Are those big answers or small answers? No. The gut feeling is wrong. Ands are small answers because this was an and. You have to have an SUV and a yellow house and a piano. And those are small answers. What are big answers? Ors. You'd add them all up. All right. My videos at servervideo.com can be searched by just scrolling backwards in time. I would watch review videos. I wouldn't just pick random ones. Good luck. Have a great day.